Greetings, everyone. By request, here is a problem from the Problem Solving with Calculus section, and it's section 4.1. I got this out of another textbook, and let's take a look at the problem. All right, so a gas station stands at the intersection of a north-south road and an east-west road. A police car is traveling toward the gas station from the east, chasing a stolen truck which is traveling north away from the gas station. The speed of the police car is 100 miles per hour. At the moment, it is 3 miles from the gas station. At the same time, the truck is 4 miles from the gas station going 80 miles per hour. And then we have two parts. At this moment, A is the distance between the car and truck increasing or decreasing, how fast. And then they give you a hint here. How does your answer change if the truck is going 70 miles per hour instead of 80 miles per hour? Now what you should do is you should right now pause this video, go set it up yourself, see how far along you could get, and see if you can solve the problem. And if you can, great. You're probably a lot better prepared to answer questions like this on quizzes and tests than having to rely on seeing my solution first. And then come back and check afterwards. All right, so let's go ahead and get to this. I've started the sketch over here. We got the north-south road. The gas station, which isn't pictured, is at the intersection of the road. It says the cop is traveling east. From the east towards the intersection, and the truck is traveling north away from the intersection. And so remember, we start to label things in the picture that are changing with variables. And so the distance the truck is from the intersection we'll just call y, and then the distance the police car is from the intersection we'll call x. And remember, we're measuring the distance between the two cars, and I'm just, for no particular reason, I'll connect the ends of the arrowheads there, but just I'm connecting some feature of representing where they are and where they've traveled from. And we'll call that z. Now, going back to the problem for a moment, we were told that the speed of the police car is 100 miles per hour. At the moment, it is 3 miles from the gas station. So we know dx dt is going to be, let me make that t look better. Dx dt is going to be negative 100 miles per hour when x is equal to 3 miles. And the reason why dx dt is negative, of course, is because the length x is decreasing as the police car gets closer to the gas station. We were also told at the same moment, so I'm just going to put an also, so I'm including that with the when x equals 3. We were told that the truck is speeding away, meaning y is getting larger, at 80 miles per hour, so we get a positive 80 for dy dt. And again, that's also when x equals 3. And wait a second, though, they said something about 4 miles away. Let me go back and check. Okay, the truck is 4 miles away at that moment also. So this is when y is equal to 4. All right, so what are we trying to find? We are trying to find the rate of change of the distance between the two cars, and whether or not that's a positive or negative value to determine whether or not the distance between them is increasing or decreasing. So in other words, we're trying to find dz dt at this moment. Let me double check that. Yeah, we're double checking that. Okay, so at this moment, we're trying to find dz dt. So this is when x is equal to 3 and y is equal to 4. So now I need a relationship involving x, y, and z so that I can derive a relationship involving, or at least involving dz dt. So of course, by the Pythagorean theorem, we'll have x squared plus y squared is equal to z squared. We'll get, implicitly differentiating with respect to time, we'll get 2x dx dt plus 2y dy dt equal to 2z dz dt. And of course, I'm going to cross out all these 2's because the common factor we can divide out by, and we don't need them. They're unnecessary now. So we're looking for dz dt. This is what we're trying to find, and we know x, we know dx dt, we know y, we know dy dt. So the only thing we don't know necessarily yet is z. But remember, x is going to be 3 and y is going to be 4, and if we remember our Pythagorean triples, when x is 3 and y is 4, the hypotenuse is going to have to be 5. We got a 3, 4, 5 right triangle, so we actually do know z, or if we didn't realize it before, we now know it. And so in order to calculate dz dt, let's plug in the values. We said x was going to be 3 and dx dt was negative 100. We said y was going to be 4 and dy dt was a positive 80. And we just calculated z to be 5. And so we have this relationship here. So we got a negative 300, and then this is going to be a positive 320. So this is going to be a positive 20 is equal to 5 dz dt. And so dz dt, excuse me, it's going to be dz dt is equal to 4, whatever the unit, should be miles per hour. And so, how does this answer the question? Well, going back and taking a look at the question real quick, is the distance between the car and the truck increasing or decreasing? Well, the derivative of the distance between the car and the truck, the police car and the truck, is a positive number. So since this is a positive number, the actual variable is going to be increasing. So the distance between the car and the truck are increasing. And the other question was the how fast? Well, that's the 4 miles per hour that we have gotten there. Okay, I'm not going to write this down. You've heard me say it. You can go back and listen to it again. But again, the distance between the car and the truck at this moment is increasing because the derivative of that distance is positive, and it's increasing at a rate of 4 miles per hour. The second part of the question dealt with how does your answer change if the truck is going 70 miles per hour instead of 80. And so if the truck is going 70 miles per hour, that changes this right here to be 70. And if that changes that to 70, that's going to change this to be a negative 20, because 4 times 70 is going to be 280, and we have the negative 300 over here. So negative 300 and positive 280 gives us a negative 20, which gives us a negative 4 as our rate of change of the distance between them. And so the distance between the cop and the truck is going to be decreasing. So the cop is actually, gaining in distance on the truck. And so that answers part B. Well, I hope that was helpful. I hope you were able to achieve a correct answer on your own. And if not, well, you need more practice. You can request me to do more videos, or you can just go to your textbook or go online and find more of these types of problems to practice. Go study.